Today's we already covered interesting topic with clouds, yeah, and with documentation. We discussed, of course, on this orange stream and on purple stream, we discussed documentation as a tests and how to improve and save time for writing documentation with Peter. You can, of course, join him and improve your project. And our next topic going to be around revolution in Java. What do you think about revolution in Java? What is this about? Hi, Dima.
Hello, hello. Nice to meet you. And
Yeah, for me, yeah, I'm with big pleasure. Frankly speaking, we're talking about virtual threads uh,
yes,
rather
not
often
only
because
virtual threads, but applied virtual threads.
oh, yes, about, of course, upload vector threads. Most of us, I mean, for me and developers working on earlier versions of Java, I mean Java 8, yeah, and virtual threads, it's Project Loom, it's just only introduced as a view in Java 19. It's not. It's just now. Colleagues who don't know about virtual threads, read about them. It's very important topic. And Dmitry, can you please tell, because your presentation, your speech, not about virtual threads, but about usage of this.
Yes,
Can
exactly.
you?
So yes, so in this talk actually, so virtual threads has been around for some time. So it's not a new concept. I mean, there has been virtual threads like fibers and so on in different language implementations. But for Java, yes, this is a kind of a, I would say, reincarnation and revolution, because there was an idea of green threads back in those days of Java 1.2, I guess, or something like that. Please correct me if I'm wrong. But the idea is that yes, thread is a heavy resource, and working with threads is hard. So everybody who was able to read and understand the book of Brian Gertz about multi-thread programming, parallel programming, is really a hero. But once again, no, making working with in parallel is hard. But still, we need somehow to get the performance. And for that, actually, we have all these ideas of reactive programming, which is like, solve the problem in some way for us. But it tends to be that it's hard. And well, now we are back to normal programming. I would say normal programming model that we learned from school, and this will somehow help us to not to get that programming so hard. So yes, this might talk will be about that thing, and the idea is that it's not just about like something like hypothetical. I will show it exactly on the product I'm working on. That means that it is already like it's still some of part of our technical preview, but some of them can already be used even in production. So yep, that's what we'll talk about. Yep.
So you are a part of revolution. You're doing your
Well, I am
revolution. Great.
just right before, like this morning, I have committed some code in the revolution. So yes, I'm happy with this.
Wow. So, colleagues, you asked me about this topic when it will start. So, it's now. Share the link on our
Ah,
translation for
yes.
your product. It's very
So
interesting.
I
Yeah,
need to
please.
share the screen, I guess. Yes. Um.
Okay.
Yeah.
So, colleagues, I want to remind you that you can ask questions in the chat here on via community or on Discord. So please write, and Andrei will help and read these questions, and Mita will answer them.
Thank you so much.
So, okay, let's go. We are muting Mita.
Thank you so
Your
much.
lord.
Yes. So once again, this is the talk I'm going to do today. So it's going to be about the product I'm working on. So I'm really happy. And since this product is mainly contributed by Oracle, I really have to show you this slide because, things can change quite dramatically. That means that if you take any business decision based on that, just check once again if something has changed, because this is something that may happen. So my name is Dmitry. I'm part of work of Oracle team working on product Helidon. So these are my, so you can write me on this channels. I read them the most, you see. So the first part, you see, I have upgraded my handle. So the first part is tweet handle, and the second part is Mastodon handle. So I'm mostly answering questions there. So if you have any questions in both of the social networks, so I'm going to be really happy to answer them. Yes, and once again, I'm part of the Bulgarian Java user group, so co-lead. So I'm now talking to you from Sofia, wonderful city of Sofia. It's quite warm here, by the way, for the season. So it's plus 13. It should have been snowing, but it's like nice here. So I'm sending a big greetings to all of your community from our community. And I really like that this conference is organized exactly by the community. So it's developers for developers. So great. So the most common task of modern development is actually written on this slide. Yes, so microservices have actually gained like big respect in the community. That means they're not suitable for everything, but for certain cases or certain test scenarios, they are the best choice. There are a bunch of talks about that on other conferences, on YouTube, whatever, well, everywhere, in the discussions, in the chats, and Telegram channels everywhere. So I'm not going to dive into why microservice is good or bad. I'm going to say that, for example, we need to create a microservice. And what would you do? So you have chosen that microservice architecture is for your project, is the choice for your project. How would you create a microservice? Well, I guess the most of you will say, I'm going to take the Spring Boot and just do it. Like, this is the obvious choice, I would say. And you'll be completely right. Like, 70% of the code now is written in the Spring Boot. And yes, it's wonderful product. It's nice. It's good. There's a big ecosystem about it. But, well, there's one issue here. It's, for me personally, it's an issue that it's not standard, which means that, like, for example, things can change dramatically and you can't influence them. So, or you can influence them mostly as a committer on code. So just go there and try to commit. Yes, but, well, it's not a standard. Well, it's a de facto very well accepted, but it's not about, standardized code. So that's why there was a big initiative called MicroProfile. And this is exactly an open source community specification for enterprise microservices written in Java. And yes, the main idea is that whenever you create microservices, if you follow this specifications, they're going to be portable across multiple vendor implementations. Currently, it's hosted under a nonprofit, Eclipse Foundation. That means that it's not like bound to someone personally, and there are a lot of participants there. So it's like Oracle, of course, IBM, Red Hat, Payam, and Sonic, and even Microsoft. By the way, Microsoft is really active now in Java world. So yes, they're contributing a lot, and they're also part of this community as well. So so these specifications are released quite often, like 4 releases per year. Once again, you have to understand this is not an implementation. This is just a document with a set of TCK tests, which are there for different vendors from all these participants, like as I mentioned, to deliver their own products following the specifications. So you can find more information in MicroProfile.io. So that means that all of this main 13 specification are specially bound for the microservices world. Many people will say, okay, this is yet another Java EE, which is heavy, ugly and I mean, well, it has all the negative from the past. Even many people will see this, say, "Oh, yeah, it's another EJB." Well, not. This is not. Yes, there are certain specifications, but if you take a look at those specifications, they are really, I would say, made for a microservices world. And microservices, since they are, I would say, well, a good example of a distributed computing system, like exactly from computer science definition of distributed computer system. That means that, for example, they are acting independently, they can fail independently, and they are all building like something bigger than just a combination of this project of each of the elements. That means, for example, if something fails, you have to care for how to do this the correct way, how to handle this the correct way. So that's how you have the fault tolerance. It's a specification, for example, that describe how would you behave and how your microservice should behave if the other side has fault, for example. You need to trace, for example, one business request can have many microservices included, and must have the ability to trace it. You have the security with job propagation. You have health check, just to check if the service is up and running and take your decision. For example, should I connect to this service or should I connect to another service? Even the configuration, not only the Java code, even the configuration itself is portable. That means that we have the decision that, for example, we want to switch the vendor. For example, other vendor has provided better conditions for us for our product, so maybe better support plan, better financial conditions, or maybe some benefits, and I want to switch it. So you just not port the code itself, but you also port the configuration, and it's also portable. So yes, this 13 main specification, although they somehow overlap with JaCoV E specifications, but they're still made specially for microservices world. And that means that some vendors have to implement them. And actually, there's one thing about them. It's nice that you have this specifications. It's nice that you have well-defined APIs and good. But what if, for example, do we ever think about the performance here? Actually, not very much, because all the APIs that we have are blocking. I would say blocking. That means that in fundamental way, they ask you to block whenever you have the wait for this or a certain function to execute. And nice, let's have a look actually how can we think about performance in a fundamental way based on a product which I'm working on, which is exactly actually following the ideas of standard approach in microprofile and non-standard but performance approach of it. So our Helidon, so it's a microservice framework and has a very easy approach. So underneath you have Netty, which is well-known reactive service, reactive web framework for dealing with the network connections and delivering information over over network in a reactive way. So web framework. And to make it really cloud native, so we have a layer on top of it, which we call Helidon Reactive. So it exactly cares about fulfilling all those specifications that I was telling you, like for example, to care for health, for tracing, for metrics, for configuration, etc., etc. So, but as a framework itself, it was built in a reactive way. So I'm going to talk about a little bit more about it later. And to deal with standards, there's on top of it we have this layer of Helidon NP. So that means that you write your microservices following the ideas of microprofile, following the specifications, and this way you make your code portable. That means that, for example, if you have written your code on some other framework, like, I don't know, Open Liberty or Quarkus or whatever it is, and you want to switch to Helidon because, for example, you have better condition and better support plans, you don't have to rewrite everything. You just drop in your code and it will work out of the box. So that means that technically Helidon itself is like two different products. So Helidon SE is a fully reactive framework, which follows the functional style of coding. So it's reactive and non-blocking. That means that it really cares a lot of performance. It has very tiny footprint because it's so small. And, it's pure Java. There is no like injections, dependency injections, all that stuff. So the only annotation there is used is override. On the other hand, Helidon NP is declarative style. That means that even those specifications from microprofile I was talking to you, they are all highly inspired by Spring Boot. That means that you just put some annotations on your code and the magic happens. So that means that writing the code, so you just annotated your POJOs and they automatically become microservices or endpoints or configurations, etc., etc. So yes, that means that in a fundamental way, Helidon SE is reactive. Once again, definition of reactive, the best one. I'm not going to dive into it a little too much because there also talks about it. But reactive allows you non-blocking access, a non-blocking way of coding, and that means that you reuse your resources as much as you can. So on the other hand, in Helidon NP, all the API is done blocking. That means that if you call something, it will simply block and wait for results. There's some APIs that allow non-blocking access. I'm going to talk about it later, but in general, you write your code in a plain old way, as I, for example, was learned in school. So you make a request to a function, you wait for the request to be fulfilled, and you just get the result. Yes. So just to mention about this two product, let's jump a little bit into Helidon NP. Once again, if you use Helidon NP, you follow the microprofile, but you get a little bit more. So that means that you get not only the microprofile specification implementation. That means that you can annotate your code in microprofile way, and it will do the expected functions for you. But you have a little bit more. So in NP, there are also standalone specifications, like, for example, work with GraphQL, the implementation of Saga pattern for LRA, and working with reactive streams and reactive messaging. But you also have the CDI, you also have the WebSocket. Yes, get a big infrastructure. You also work with a database, for example, with persistence. So that means you get a little bit more. And if you can see here, I always love this picture because the footprint is really tiny. But the good thing is that we're giving 3 ways of distributing your product. So one is a plain old Java jar file, so fat jar with executable. The other is we support JLink, custom image generation. That means that Helidon itself was built in the post-9 world with Java modularity included in it. And that means the code itself is fully modular. And as the code is modular, you can just throw away the code you don't need at all. And the other option is native image, because everybody is familiar with raw VM native image. So I'll just put in some light in my room. So that means that it can generate native image. It's a pure executable. It's very fast, cool, but with some limitations of language. And you don't have the optimizations that JVM can provide you running from time. But it has wonderful startup times. And what is good is that's we are we're the only one who support CDI. CDI is a constant dependency injection. in GraalVM, like following the full spec, that means that you can just drop in all of your CDI extensions. This is, by the way, the extension mechanism of Helidon. If you don't have any special features or something, you just drop in CDI extensions and it will simply work, even in GraalVM native image. Now it's fully JaCoVified. So if you, just small product positioning, as I say, if you want to start working with Helidon, now it's done very easily. So you just go to the Helidon.io website, and there is a starter there. And the starter allows you to generate your project. Another way to do this is to use our CLI, actually. So, but I'm going to show you a little bit later how to use it. So just let's jump a little bit into the demo, just to give you a flavor what it is to work with Helidon. So go to Helidon.io. Go to starter, and you see there's a starter, but it's not typical starter as other colleagues do. So we are following the idea of like a step-by-step generation of your project. So you just create a application, can be custom, like you can take how you process JSON. You can care about security, whether you want to secure your application. It will give you all the modules that you need. Once again, we are modular. That means that you just check the models you need. If you need some implementation, not in implementation, but delivering your application somewhere in the clouds, you can generate Docker file, Kubernetes, and for example, we are very much associated with a Verrazano project. So Verrazano is a way to run your application in the clouds. You can generate the descriptors there. You have everything, health, tracing. It can be microprofile, micrometer. So you really build custom application. And if you work with database, for example, you have all the support here. So you just tick whatever you need, and that's probably it. So, but we will go back to quick start, because this is the easiest way to create this project. So it's simply download it and CD downloads, I guess. Yes, it's in the downloads folder. And we will simply unzip the project and open it in our favorite IDE project. So let them give it some time. So I'll just put it here. Oof, wait a second. Where is it? So. Yep. So what do you see actually? It's the flavor of it. It's very, very easy. So if you have a critic resource, you just annotate it with path. You just annotate, for example, with getter, like get default message and maybe some custom messages. And yes, with simply 2 annotations, you get your microservice ready. But once again, if you see here, everything is blocking. So it's done in a blocking way. That means that when you write the code just the way it is, and it simply works. If you want to get message, just get the message. It's really, really straightforward. To make it run, we just build it. So Maven, you can simply just clean package it, yes. But if you want to do it with better experience, for example, you can also use our special CLI. So if you download the Helidon CLI and run it with dev, so it will automatically track all the changes that you do in your code and rebuild everything for you. And once again, if you say a microservice, cloud native, that means now if we do curl greet, yes, it will work. It will give us the hello world. So as we expected here, for example, this is the greet resource. And we say like for the default get, it will just give you response with hello world. But not only that. So cloud native means that you are really ready for health checks. You see it's up and running. You can do metrics. It means that it already out of the box provide you everything you need to run in the clouds. Open API, etc., etc. And that means that creating microservice in a blocking way and writing it in a declarative blocking way is extremely easy with Helidon. And it runs nice, it tracks your changes, you have all the tooling, which is good. So nice, but once again, there are some issues with that. And this main issue is that it is nice if you're mainly focused on portability, but it's actually, what about, well, if you're serving like average count of users, it's nice. But when it comes to performance, when portability is not so important, then what would you do? So in Helidon world, we will just use this Helidon Reactive Player. And this Helidon Reactive Player was previously called Helidon SE. And what does that mean? That means that we just throw away all this magic of the micro profile, all these annotations, etc., and give you the same actually specifications that you had to fulfill, but they are all done in the reactive way. Reactive way, that means that they are all non-blocking, they all respect back pressure, and they're following this wonderful reactive paradigm. Yes, but this becomes like a non-standard solution. It's much more performant if you take a look at the numbers. So it really throw away all this overhead given by the context dependency injection, given by this annotation processing that you have to done for an application, all these extension mechanisms that you have there. They sometimes happen in the runtime, and they really eat a lot of your processing time. And yes, if you throw away all this stuff and leave only the reactive part, you become really, really performant. And actually, that's what, for example, is done. You will probably ask yourself, okay, Helidon, we haven't heard much of it, but as it was developed mainly as a Oracle's internal framework for internal project, and then it was open sourced for the community. Once again, it was one of the first ever products which was open sourced within Oracle in Apache 2.0 license. That means that everything is available in the GitHub. So you just simply go to GitHub Helidon.io. Nice, good, because we now have our own organization. It's not affiliated with Oracle, so we have different repositories. It's an organization, so if you go here, and that means that all the issues, all the pull requests are here. It's all the discussion is done here, and most probably in the Slack channel, but it's not closed code. So it's already here, and you can contribute there. So we accept PRs. Yes, and if you give it a star, so we are very close to 3,000 stars. So if you give it a star, it will be really, really helpful for us. So, and if you once again remove all this, I would say, overhead, then it becomes really performance. And this performance is used in one of the biggest projects, for example, Oracle Hospitality. All the bookings in the world, you'll be surprised, are really, for example, for apartment, for a hotel room, for a cabin in a cruise ship, whatever it is. So you book it through one of the websites, but the booking itself actually go through a system called Oracle Hospitality. It's the most widely accepted system for booking, and it serves like millions requests per second. And doing it in a standard way with microprofile would have been just too much. You have too much overhead, which has to be processed. And that's why they did it fully reactively. So there are several microservices which are very small. Like each of them become of a 10 megabyte size, and it can serve millions of requests exactly in this reactive way. How would you achieve this in Helidon SE? So we have decided that it's a good idea not to depend on anything else and to create our own reactive engine. And this reactive engine is created following the Java, 10? I guess it was 10, just correct me if I'm wrong. This concurrent flow API. So once again, in Java 10, they introduced these interfaces for publisher, subscriber, subscription, and for you to fulfill. And we have used them to create our own reactive engine for, reactive processing of many requests. So we have our own reactive operators, and as you see, they are all easily constructed using two main construction, which is multi and single. I believe most of you are familiar with Spring, so there you use flux and mono. It's the same in Helidon world, simply use multi and single. So that means that, for example, if you wanted several operations to be applied to some data, some set of data, or stream, I would say, of data, you just use multi. If you have only one element that has to be processed in a reactive way, you just use single. And Helidon has a very good set of reactive engine operators. So it's not that infinite in, for example, Project Reactive, but it's quite useful and good. So you can easily chain this operator. So you can just click publisher, then you have process this stage, and then you can compose them, for example, together to give a aggregated result. So it's easily done. Actually, the funny thing is that single and multi, for example, are following the completable future, so they're extending the completable future itself. So we're reusing a lot from Java itself, which makes it once again, we're not depending on anything else except JVM. So, for example, why is that happening? For example, for banking solutions, you have to do audit of all of your dependencies. So we had this as an issue, and that's why we said, let us do our own engine. And actually, we're quite happy that this engine was contributed by David Karnak himself, who was, who is the father of reactive programming itself. So you will say yet another engine. Actually, yes, but it's one of the purest engines I would ever see, actually. And it allows us to do everything in reactive, and we compare to our competitors sometimes we're even twice as fast as the others. So, and as a result, if you have this reactive engine, you can create your fully reactive web server. So that's what we did. And that means that in Helidon SE, you just take a web server, it's fully reactive, and you start working with it. So actually, let me show you this in the demo. This time, we will use the same Helidon application, Helidon, but now we will create a project with it, in it. And the same as in those, in the starter, we just answer a few questions. This time we will create the flavor of Helidon SE. We'll use quick start with JSON, I don't know, P processing, for example. Answer some question. We don't need the developer loop. I've already showed you right now. So we will just create, we have just created the project, and we will just open it now, quick start. You see, it's very fast. And now you have the same microservices. I show you the same greeting application, but now written in a reactive way, following the reactive paradigm. So what you see here, it's just a main function. I hope you can, by the way, see my screen. So I have, I think that this font is nicely readable. So just write me in the chat if I need to change it, but I believe it's okay. So it's just a main function, pure main, nothing else. And in this main function, you create a web server object. You just configure it from somewhere. So we're following the builder pattern. And then it starts. As it starts reactively. So you see this single. So the single means that there is an object which contains the server, and you can work with it completely reactively. So when the server is ready, so just say the server is ready, and okay. In shutdown event, just print the message. Exceptionally, if you probably all have watched the famous Venkat Subramanian videos about what is functional programming, what is reactive programming, so you know there are three streams of events happening there. So there's the data, the control flow, and the exception flow. So that means that they, like, you know, have data, then you control the way it's processed, and then you have this exception flow. As if the exception happens, you can handle it gracefully. So that means if some server can't start, you exceptionally say, well, something wrong has happened. And then you just create a routing. For example, you just register a route for a service. And once again, the service is something extremely easy. It has only one function to override, which is the update method. So this is the only annotation that is used in Helidon SE. When you say, for example, for this greeting route, please use this handler. And this handler is reactive, so it receives only request and response. And as you see, it reactively processes the data. So if you have a request, for example, as JSON object, so it will return you a single. Single means that this is something as a reactive construction. Whenever it's done, you can say then accept. So whenever it's available, the next thing you will change is set on it is like update greeting. You will call this function, and whenever it's done, you see this completion awaitable here. Whenever it's done, you can return it, or if exceptionally something in the middle. Once again, I'm following the reactive programming here, a model here. So whenever something happens, just send an error. And you see, it's a reactive way of doing stuff, following the reactive paradigm. I'm gonna just start it right now. So the start, I can directly start it from the IDE. Because it's pure Java. There is no magic here. I don't need to make extreme scripts about it. So I just start it. And if I just curl the same stuff I had, it will do the same for me, absolutely the same for me, but now in a reactive way. I will still have the same endpoints, read the health checks, read the metrics, yes, but now it will be much more performant. I will give you numbers later. It will be much more performant, but as you see, it is a completely different paradigm. It's a completely different way of thinking. That's why, as you say, we say Helidon has two flavors. Actually, one is based on another, but still I would consider them for myself as different products because you just code it in a different way. And as we do this, it's really, I would say, it's just different. And if we go back to where was this demo? Yes, slide. If you go back to the description, for example, it's very much suitable for reactive messaging. So whenever you have a big flow of messages, and if you follow the microprofile reactive messaging model, so we have a wrapper over, like an abstraction over them. You can pass your message through different message brokers, and you can do it absolutely natively in terms of Java code. So you just create this channel, and you work with them in a reactive way. You can have multis, you can have singles. You just reactively process them, like do maps, for example. Then you can pick a message from somewhere, then you can just print it, use it for each. There's only one thing about reactive. Once again, this is a fundamental thing. Once reactive, you always have to be reactive. And what does that come from? You can't mix blocking code and reactive code. And here comes an issue, for example, with work with database. Currently, all JDBC drivers, there's an initiative, our RTDBC, which is reactive, but the JDBC drivers, for example, are blocking. So they have blocking API. How would you deal with them if you want to use them reactively? So we have cared for them and created our own DB client, which is like a wrapper over this driver. and it provides you a reactive API to work with blocking drivers. But these blocking drivers are like run in a separate executor. So that means that you receive this way of asynchronicity, asynchronicity. I'm not sure I did if this such a word, but you can work them asynchronously. So that means that you can do the same for web clients. So if you have to talk to another service, you can also do this reactively. So that means that to make code much more performant, to run it reactively, we have to do all the instruments together to be fully reactive. So we actually did it. And here we have this Helidon SE product. But the practice have shown that reactive programming is hard. Yes, it is hard. I'll be quite honest. And it's very hard to work with exceptions. It's very hard to troubleshoot, to debug, to unblocking code is a blocking code is much easier just to put a debug point and it will simply work. In reactive programming, it's not the same. So if the reactive programming is too hard, what would you do? So now you have only two choices. But here we finally eventually come to this revolution that actually is happening on our eyes. With this release of JDK 19, we have become the possibility to work with virtual threads, which were introduced in this research project called Loom. So it is really here. So it was released as a job like this year in the beginning of I would say April. Yes, April. So it already became something like, not just happening somewhere, something realistic. And what do you have? So Project Loom defines something called virtual thread. Virtual thread is an entity which actually by API copies the real thread. As you know, working with thread is hard. Threads themselves are like a very expensive resource, and you can't create too much of them. Because, for example, if you create like more than 400 threads on one machine, and you have only like, I don't know, 10, 16, 20 for like 32 or 64 cores to actually work with them, most of the time they will be blocked and waiting for the resource to be available. And since they will be blocked, the resource will just stay and do nothing. And just keeping that resource is hard because all the stacks that you have there, depending on the JVM, can be megabyte to several megabytes of size. You have to keep them in your memory. And switching contexts is a hard operation. That's why actually reactive programming was introduced, because it's non-blocking by its nature. But what we have here, so you have two main categories. So the carrier threads are exactly those operating system threads that we had, and virtual threads, they operate over them. So virtual threads are like mounted by the JVM over carrier threads. So when the virtual thread is blocked, so there's a scheduler who actually sees how the virtual threads are worked. So it's unblocked, it's like unmounted and given to the resources given to another thread. Whenever it's available again, it's unblocked, the scheduler will see which thread should receive this resource and give to him. Actually, it's based on continuation. So continuation is also like a computer science structure. So it's based on that. There's currently no API available. And those properties are, and underneath you have for join pool for the carrier threads. So, and the main idea is that the virtual threads, they can be millions of them. They are now became a cheap resource. They don't really block real threads, and they're threads by API. So in JDK 9 Plus, they are already available as a preview features. So there's only like a little bit more new methods to the executors. So it's a virtual thread, or how to create a virtual thread. And once again, what is good about Helidon? Out of the box, we do support those threads. So it means that whenever we need to process the requests which are coming as a server from our clients, with one option, we can switch the executor, the thread pool that is used underneath for netty, from real threads to virtual threads. It's only one option. Currently we can, even with the second option, we can just enforce it. I will show it in the demo for you. That means that we can, out of the box, just change one property and already use the virtual threads for netty executor. So what does that actually mean? That means that allows you to write the application which are blocking by their nature with performance, non-blocking or close to non-blocking, with blocking paradigm. So that means that all this bloody enterprise that you have in the world, which is written in a blocking way, following standards, can now be much better utilized for your enterprise application. But once again, there's one issue with Helidon. So we are changing the thread pool executor for the netty. Netty is asynchronous by its nature. Since it's asynchronous by its nature, it's exactly what I told you in the next slide. It's like putting an electric engine on a petrol car. So, this electric revolution that we have now, so you can really switch, the engine, receive big performance, but you still have the gearbox. You still have the way you actually architecture of your car here is still following the petrol standards, not the electric standards. Actually, I'm going to show you in the demo how it's done in Helidon, and you will see the difference. And we have decided, okay, since now we have this non-blocking, blocking way of writing code, and we have this, for example, a netty, which is asynchronous by its nature. And to care for all this asynchronous stuff, there's a lot of magic that is done there. Let us do our own server, which is fully blocking, and let the JVM decide how to manage the threads. And we have created Nima, which is the first virtual thread-based web server at all. So that means that it's fully synchronous. Even the code is fully synchronous. It's built from ground up. It's only using JDK and together with Java team. So we have some benefits here because we are one chat away from the Java and JDK team, from the performance guys and from the architects, and we're able to collaborate tightly with them. And we have created this server. So it contains, Nima is like a framework which contains Nima Web Server, which is part of the additional libraries. And it has performance, which is, you will see it later. So as Helidon is based on this layered architecture, it was extremely easy for us to just switch the layer, which was underneath, from reactive to blocking. So that's why care for your architecture, care for the architecture that you have in your products that you do. So for us, if we have this layer, we're going to switch what had underneath. And we have completely rewritten some of the components. They're still in progress. Once again, it has just been released, this Java 1, like a few months ago. So we're really on the edge of the revolution. So we're rewriting all this non-blocking stuff, reactive stuff, to blocking stuff. And as a result, Helidon has become one of the world's first consumers of virtual threads in a, I would say, applied way. So talking about virtual thread is nice, but we really do use them and apply them in real-world applications. So currently we support everything like HTTP 1, HTTP 2, gRPC protocol. We have to rewrite it, by the way. It's now performing very good. So WebSocket, it has testing, TLS and NTLS support. So it's very much extensible. You have access lock, you have support for CORS, you can serve your static content there. Telemetry, observability features are already there, and a lot more is coming. But what is cool, it is all written using the latest stuff available from the JDK. There's no legacy underneath. So it uses virtual thread for performance. It uses enhanced switching for much cleaner and better readable code. Since we are framework, so we use sealed classes. They are really perfect for writing, hierarchies of components for APIs and so on and so on. And we use system logger. So it's only JDK. So, and currently we're using this thread model. So for each usage, we have 2 virtual threads for connection and for data. For HTTP2, we have 2 virtual threads per connection, and 1 for if you need to stream something with HTTP2, you can have another thread. So, and all the routing is done in virtual threads and can block as much as you care. The JVM will take care of it. So why would you ever need this? Sorry, I have to switch my lamp off. I have not considered that it will get dark so fast. Instead of creating this code, which is asynchronous, with a lot of hardware, you just do simply blocking code that I, for example, was teached in school, and as easy as that. And as a result, we get the following performance. So if you compare to Netty, now we are a little bit better performing than Netty. Because once again, we just thrown away all this asynchronous stuff, and it's now fully blocking. Now the JVM, only JVM cares for that, and there is no overhead that has to be processed. But if we take a look at the Helidon NP, which uses blocking Netty underneath, and just replace it with Nima, the performance is times better than we have previously. Once again, the idea is not just to replace an engine in the car with electric, but to build a completely new platform which is suitable for the virtual thread environment. And that's what we need. And let me show you one demo right now. So yes, I will just open a project which is Helidon Loom. Yep, I will just close the other ones. Helidon is here, close the other ones. So I'm going to show you different ways of actually writing the same stuff and see their performance. So first of all, we have a very easy server which has 2 main resources. One is processing quick requests, it simply returns done. And other one is processing slow requests, it just slips some time and then returns something. That means this is an imitation of heavy load, and this is an imitation of fast load. And as easy as that, this is the server. We have 2 clients which are actually just sending request responses, and monitoring the result. The same is written in a reactive way. If we take a look at the reactive way, so the service is really simple. So now you have the, you can imagine how it's done on in a reactive web server. So it's very easy. Just send a response. And here, because we are non-blocking, it was a little bit strange to see this executor, but it's just like imitation of blocking in a non-blocking environment. So yeah, once again, by the way, take a look how few code you have. It's just a main function. You can just run it. And the third option is the Nima option, which is exactly the same thread, but it's written, not the same thread, the same server, but it's written in a completely blocking way. You see how less code you have. You just create a server, and you just create an HTTP service, which is extremely easy. So you just sleep and send a response. You don't have to make all this fancy executors and so on and so on. And let us actually take a look at what we have. So I'll just show you the performance, actually, the difference. So terminal, I have a special Windows group for virtual conference, and what we have here. So, by the way, I haven't shown you the main thing. And the main thing is that we can work with server, just changing one option. So just changing this option, we will enable virtual threads in Helidon NP. And here with no loom, we will just disable them. Once again, you don't change the code. You just change the executors which are underneath. And let us play with it. So what we have, just give me a second. Yep. So we will start the server with no loom option. It just starts the server, and now we will start the clients, which is Java jar. This is client slow. Yeah, we'll send request and response. Java jar client quick. So what will happen now? Here we actually start seeing that the slow response is occupying all the thread time. It simply sleeps, but the quick response are not able to be processed because the threads are blocked. And you see a lot of errors happening here. So the CPU utilization is really small, I would say, because the slow threads, they block the other threads, and the web server simply can't switch to other threads. And that's why you have a lot of errors happening, and the utilization of the CPU is really bad. Nice. So now, as an official option, we have this reactive way of doing stuff. So where is it? So if you write it reactively, what will you see? Suddenly, you are able to process the slow threads, which are, occupying a lot of time, but you still see that the quick threads are also processed. You start in an asynchronous way to utilize the resources of your processor much better. So if you do htop, you will suddenly see that your processor is nicely occupied with doing something useful. And you see, it really returns you a lot of responses with practically no errors happening there. So reactive way of doing stuff. Oh, sorry, my lamp is a little bit, I have to switch it better. Yep. It allows you to utilize the resources in a much better way by simply non-blocking way of doing stuff. Okay, but we see that saw that reactive is hard. Let us switch the loom option on our Helidon server. So it's simply changing one property. So it's now using virtual thread, and what you see, suddenly of this 0 returns a lot of errors, we suddenly start utilizing the threads in much better way. It's really close to what we have in reactive way. It's less now, but you see the JVM is getting hotter and hotter, so it's processed better and better. But you see that just switching to virtual threads as a pool allows us to utilize the resources that we have in a much better way. But once again, it's like putting electric engine on a petrol car. But even this helps us a lot in our framework stuff. But now if we put Nima on, so Java jar, we have to enable preview because in JDK 19, you already have it in JDK 19, but you have to enable a preview feature. And all of a sudden, the same stuff is done in blocking manner. You still start doing the same performance, or close to same performance, but in absolutely blocking code, which has no tricks. Like, for example, Netty has some tricks with the JVM. It uses some native performance stuff, operating system dependent stuff. And you start receiving the result. By the way, it's still research function, so it's not very much optimized for Mac. On Linux, you will have better performance. So you see, just switching to virtual threads, the same code works much, much better and much more. It utilizes your resources much better than it had been previously. So this is the applied virtual threads. This is what happens like on our eyes. So we as a framework started using it in our system. So what is the problem we don't solve? We have 2 more minutes. Abstracting thread, abstraction itself, is when you use all the threads without switching the task. So microservice nature of using the resources is that we have small tasks which are running fast and which may have some, for example, some I/O data rates. So they are not obstructing the thread. If you obstruct your head, there's nowhere you can get more performance. But here, if you are using small portion of thread time, and others think is like, for example, reading from database, you can still give this time which you're blocked to other threads. So the funny thing is that everything asynchronous in terms of operating system actually degrades performance. So if you do sockets asynchronous, they will degrade. So you have to block again. The same is for server socket. Blocking mode performs much better with virtual threads. So now the biggest challenge is actually to forget the asynchronous, because this way the code works much better. So we have to completely rewrite HTTP2 and gRPC, but now they perform even better because, once again, we don't need to use asynchronous stuff in those protocols. They're simply blocking. And as you see, we are rewriting the models right now. So the main target of this talk is that this revolution is actually happening on our eyes. You solve it with real numbers. And now for performance, you really have to unlearn to do reactive to get the maximum of it. So we're really short of time. So Helidon is a nice playground which we are having for our customers to use most performance available. So I took you to a small journey from blocking to reactive and now back to blocking, but with the performance of reactive. And if you want to learn more, we have a bunch of social networks, links, and whatever it is. Just go there and you will find all the information about Helidon, how we did it. And we are quite happy that our customers are so much satisfied with this performance change that we have. They don't have to rewrite anything. They just have to turn on one option. And Nima will make it even better because it's pure implementation of which is depending only to JDK, nothing else. And that makes us quite unique. So once again, thank you for this opportunity to talk to your community. And I believe that you will try it. And whenever you find issues, just report it. As we say, we are open sourced. Just submit an issue. Unlike other projects, we have even a special person who actually is on duty to care for customer requests and responses. Thank you very much.
Okay, Dmitry, thank you for your talk. We have a couple of questions.
Okay.
What do you think about future of reactive frameworks? Does it really make any sense now?
I would say, you see, for enterprise, no, not anymore. I'll be quite honest. But there are certain situations where reactive is better. So there's, for example, with completable future, if you send some requests to many services and you have, for example, function either of them, you don't have to process everything. So you can just have the first result and cut off the others. So there are situations when reactive is good. But once again, this does not cancel the reactive. I mean, you simply don't need it to write performance code. If you need reactive, use it. But my personal opinion that you won't need it so much time.
Okay, got it. Is there any way to do some kind of abstraction of virtual threads with Java 8 or Java 11? Because most of us are working with Java 8 or 11. And only some
once again,
people with Java 17.
there's no abstraction for them. So virtual threads are by API the same threads as we used before. So if, for example, the community somehow say, we will backport virtual threads to Java 8, you will simply have it available there. But once again, it's a very deep fundamental change. And you cannot abstract them. By abstraction, virtual threads are the same threads. What makes them really, how you say,
clear for understanding.
This is the fundamental thing, that they are the same. You don't have to change anything. Underneath happens the magic. By API, they're the same.
Okay.
But they have only one other function to change: is the thread virtual or not? So, is virtual? Yeah, this is the change.
And in which situation it's better to use real threads, not virtual?
Well, if you need to abstract, so exactly, if you really know that this particular operation will take all of the thread, for example, for a long time, you have a big computation to do, virtual threads won't gain any performance for you. Once again, there's a very nice talk by Ron Plesser on Java 1. By the way, Nima was presented with Ron Plesser as well. So if you go to this talk, he will tell you exactly what problems virtual thread do not solve. Like this is important. And here, for example, once again, we say what we don't solve, the abstraction. So if you use the thread all the time, but the nature of microservices behavior is that most of the time you receive a request, or you have to go to database, for example, to search for some entity. You go there, and this waiting time, it simply do nothing. But the task itself, go search for database and return, is quite I would say short, and that's why you don't abstract the thread. You are just using it, but now you use it wisely. So that's it. So that's why we are virtual threads applied, because this is something which is really suitable for virtual threads. Yeah.
Oh, okay, I got it. Do we have some drawbacks in virtual threads?
Well, it's still we had some, by the way, but you see, it's still not stable, I would say. So and it's still depending on operating system. So we are now mostly focused on Linux environments, and as I told you, for example, you even saw it in my data, but in my runs, that I'm now on Mac, and they are performing not as well on Linux as on Linux environment. I'm not sure how it's done in Windows. I know that in Windows there are issues. By the way, we found some issues in virtual threads by our customers using it on Windows, and we have submitted this to the JVM team, and they are now working on them. So it's still experimental, but we're on the edge of this revolution, I would say. With Java 21, I guess the virtual threads will go out of preview and will be production ready. And as they are production ready, all these drawbacks will be fixed. So that's why we are now exactly examining what drawbacks can be.
Do you know some timelines when we can try this?
Well, you can try it right now because it's already available in JDK 19. You only have to enable preview.
Okay. Got it. Thanks.
Mm-hmm.
One more question. How do you think, can Helidon replace Spring Initializer? Start Spring IO.
Well, we're working on that. Spring is a vast ecosystem, and competing with Spring is hard. But once again, it depends on what you search for. If your project are like throwaway, do it once and throw away, then yes, Spring is awesome. But if you're doing something for a longer time and you need to follow the standards, or you need to port something from other platform, which is now actually, by the way, with this cloud wars that we have right now, for example, porting from one cloud to another is also an issue. For example, there in some cloud you're mostly focused on, I don't know, Quarkus-based stuff, and then you need to go to another cloud, which is forced more on Liberty stuff, for example. So the porting of this code is a problem, but you have to rewrite it. Some of the business decisions are taken there. And as for Helidon, it's hard, but once again, we have our own customers, which are very, very fond of it. And this big game changer that we have right now can, attract more customers. And once again, if you already started using MicroProfile, you simply don't need to do nothing. You just run this code on this environment, and it will perform better. So you get it for free, I would say.
Okay.
That's great.
Yeah.
Thank you very much. I'm just joined to you, and first of all, I want to say thank you. You're really making revolution, and we are waiting for you making Java great again.
Absolutely.
Performance. So fantastic and very interesting. So, colleagues,
Okay.
I want to say that you, Dmitry, Andrei, and all who watch us can proceed with discussion in Discord. And already we have here a link. Andrei, can you please copy paste a link for right room in Discord? Copy paste in chat. So perhaps we will have additional questions there.
Oh, they want my birthday. Well,
yeah.
I will choose random.
Mitya there. Andrei already put it here, the link. Colleagues who are with us, please don't forget to like video, or it's not video, it's a stream, and pass your minds about virtual threads and so on. And
thank you so much.
Thank you, Dmitry, that you found time and tell all this, because frankly speaking, not each day, but very often we're discussing what about virtual threads, how they making things, and what next. But we see that not only virtual threads introduction, but Helidon Nima, and you're talking that Spring can be in problems in future.
Absolutely. If you don't apply them, yes. But once again, we rewrite it from scratch, so that makes us a lot of.
Sure. Okay, colleagues. Thank you very much.